Okay, so thank you for watching this video. So this is our last video for sample problems. Okay, so for this problem, we want to find conditional variance. Conditional variance for this, right? So we just want to find the conditional distribution. So let's say we want to find this n. I want to find the distribution for this n under this condition. So n plus s equal 2. So n plus s equal 2. So n can be from 0 to 3. S can be also like from 0 to 3. So n plus 2. So we just check all those cases. N plus 2 equal. No, I'm sorry. N plus s equal 2. So can be like a 2 0, right? Or 1 1 or 0 2. Only these three cases, right? Okay. So here n, let's say, so n can be 0, so can be 1, can be 2. So n equal 2 is the probability is thus like a 2 0, like n equal 2, s equal 0. So n equal 2, s equal 0 is thus. So and 1 1, so n equal 1, s equal 1 is 18, right? And n equal 0, s equal 2. So s equal 2 is 1 0, right? But this is not a distribution because addition at all probability is not equal 0. So we need to adjust that. So we just divide by total. So total is 40, right? Okay. So then this become a distribution. Okay. So maybe we simplify a little bit, like so n equals 0, 1, 2, and the probability can be 40 over 10 to 5 over 20, like 5 over 20, and 9 over 20, and 6 over 20. Right? Okay. So by now find this variance really easy, right? So then find this variance equal n squared minus square of n. So n squared is 1 times 9 over 20 plus 4 times 6 over 20. Yeah. Minus, so n is 1, just 9 over 20 plus 12 over 20, right? Yeah, this is square. Okay, so this problem is just from joint cumulative function. We want to find the variance of x. So from joint cumulative function, we can get a cumulative function for x. So what is f x? So f x, we say we just let y, take y, largest one is y equal 100. So this equal x 100 and x plus 100 over this, right? Cancel simplify that, cancel 100, so we get this equal x plus 100 and 20000 20,000, right? Okay. Okay, so then we can find the density function, just use derivative. Yeah, density function for x. So density function is equal so 2x plus 100, and this x is between 0 to 100. So now the problem become regular math problem, right? So find Vx, so just equal x squared minus, yeah, so just do some integration. So for this problem, we want to find standard deviation of x. So here we have joint density function. Then we can find this marginal density function first. So this equal, we say just equal for fixed x, we just add those y up, right? dy. So y from 0 to infinity. So for fixed x, so we just integrate y. So this integration for y, so we have this, like for y, say, so this is exponential distribution. So exponential integration, so we have this, like negative lambda x dx equal 1 over lambda. Okay, so we can put, let me say, so this equal 13 is negative 0.5x, so therefore this dy 0.2y, so this is a 0.2. Okay, and 0.06 is negative x, here 0.2 is just 0.2, so minus 0.06 is negative 0.5x, and here is 0.4, yeah. and the plus is negative x and 0.4. So we have two parts of 0 is, oh, I'm sorry, is negative 5x, yeah, forget it as x, yeah. Okay, so we put this and this together is 0.5x and is negative x, and is negative x, we found this one cancelled, yeah. Okay, so this just equal, finally we get this equal 0.5 is negative 0.5x. So this just we say this just follow exponential distribution, this lambda equal 0.5, right? Okay, so now what we want to find the standard deviation of the standard deviation for x. So for this we have this, like for Vx is 1 over lambda square. Okay, so standard deviation of this equal 1 over 0.5. Yeah, so 1 over 0.5 square. Okay, so standard deviation sigma equal 1 over 0.5. So this equal to. Okay, so I think answer is there. Standard deviation is 2. Okay. So for this problem, we want to find standard deviation of this standard deviation of the claim amount. So we want to find the distribution for this claim amount. So let's see. So this x can be 100, 500, and 1000, right? So what is the probability for source? So here we have 3 locations, but we pick them for each. Yeah. And let's say, and if the pick one from territory 1, territory 2 the same, because it's an equal number of claim in each of 3 territories. So there's a probability that just 1 or 3 multiply this, right? So this is just equal 0.8. And then this is just the average for this. So 0.008 plus 11 plus 20. So here is 39, right? So average. So this equal. And this average is 0.007. So we can easily find this Vx, then sigma x, right? So Vx just equals this, like x square minus x square, yeah, e square x. So this is just some calculation. So such a problem, so easy, right? So for this problem, we want to find the probability. So here's find the probability that the storage bin contain more core at the end than it had at the beginning. Okay. Okay, so let's check like so the story is it says we have this storage bin that is half full. Okay, that's we have half full, and during the week 20 loads added. So here added some 20. So each one, so we can say like added L1 plus L2 plus L20. So 20 loads added, right? And each one, say Li, follow this normal distribution with mean 1.50 and standard deviation. Okay, thus. And then here remove from storage bin. So load this is remove four like a four railroad cars. So remove, so we can put this as a car 1, car 2, car 3, car 4. So those amount, those CI follow this normal. Mean is 7.25 and standard deviation thus. So in this being, some is some added to and some removed. So what we need to find is added in is more than removed out, right? We just want to find this. So we want to find this probability that L1 plus L2 plus L20 minus C1 minus C2 C3 C4 this is larger than 0. We want to find such a probability. Okay, so each one is normal. So then we can say like those things follow normal. So we just let all those things as X, or let it as T, right? So we say T follow normal. So mean is, let's say mean is like 20 multiply this 1.5. So minus 4 times. So mean for this C is 7.25, right? Means this. And standard deviation, so we say mu is equal to this 20 times 1.5 minus 4 times 7.25. So let's do calculate find this first. So we find this equal 1. So mean is 1. And variance, let's say sigma square. So this sigma square is equal, like I saw here. So the formula for sigma square is coefficient square multiply and then this sigma. So this sigma is just 10 L is 10. Each one is sigma is. Let's check it. Let's see what is variance. So here standard deviation is 2.5. So here we cannot use standard deviation, use variance, add them up, right? 2.5 squared. So here the plus. So let's say like we have this like y, like let's say suppose like we have this variance for a1 x1 plus a2 x2 plus a3 x3. So the formula is a1 square. So we variance for x1, right, plus a2 square vx2. The formula like that, right? So plus a3 square variance vx3. So this become 1 become 4 times variance for the C. So C is 50 square. So we find this equal 2.25. Okay, so we know there's T follow this normal. Mean is 1, and standard deviation actually become 1.5, right? Sigma become 1.5. Okay, so now the problem means we want to find this probability. Total T is larger than 0. such a problem become easy, right? So changing this to z, using so 0 minus 1 over sigma. So this equal c using negative 0.67, and check the table, we find this equal okay. So for this problem, we want to find the model. So model is, what is model? The probability is highest. The point that make the probability the highest. The model of what? This is, we want to find a model of those total number of claims. Total number of claims on the policy in the next 10 years. Okay, the total number. So here we have numbers. So we have a good driver or a bad driver. So total numbers. So we put good as n1, bad as n2. So we want to find. We let this n equals this. So we want to find which number make this total number n is probability the highest. Okay. So for this one, so we just check. Okay, so n equal 0. So let's say like what is the probability n equals 0? So we just check it out when n equals 0. So for n equals 0 is easy. Just the n1 equals 0, n2 equals 0, right? So just 0.5 times 0.2, like equal this. So then n equal 1. So n equal 1, total equal 1. So could it be two cases, 1, 0, 0, 1, right? So n1 equals 0, 0.5, 0 and 1, n2 equal 1, 0.3. 1, 0 plus 0, 1. Oh, no, 0, 1. This is 0, 1. 0, 1 and 1, 0. So 1, 0 is 0.3 times point. So this 0.3 is n1 equal 1 and n2 equal 0. So 0.2. And so n equal 2. So n equal 2, we have 3 cases. Can it be 2, 0, 1, 1, 0, 2, right? So just like that. So n equal 2. So 2, 0. 2, 0 is n equal 2.2 and 0.2. So 2, 0. So 1, 1. 1, 1.3, 0.3, and 1, 2, 0, 2, so 0.5, 0.4. So we can find like this, just let's say 0.0, this multiply this, this multiply this, this multiply this. Yeah. So n equals 3. So we can find the way very quick. We can find quickly the n equals 3 is 3. Say let's here 3 times this, saying this times this. Yeah, right. So this equal 0.0 multiply 0.2 plus 0.2 multiply 0.3 and 0.3 times 0.4 and 0.5 0.1, like this, like okay. So we just check it. Oh, so just we just compare this, and then finally we find this is the number. This is the largest. So this model is n equal 2. Oh, okay. So for this problem, let's say we calculated the variance of total amount of insurance company pays. So we want to find the variance of total pay. Yeah. So total pay, we have two things now. Pay this and pay this. We have two treatment. Okay. So people, we have 15 people. So for those people, 15 people, each one has so much probability to have those treatment, and those probability having this treatment. Okay, so let's say so we have two cases, like can only one treatment or two treatment. So we also can consider this, like we just focus on this treatment. Suppose like let this as x, for let x be the number of people, need those treatment, radiation treatment. Okay. If you just only consider this x, forget this the y, just focus on this treatment. So we know this x actually follow binomial distribution, right? We totally the binomial distribution. Totally we have 15 people. So among 15 people, how many will need this treatment? So need this treatment is 0.9, right? So this p, the probability for treatment this thing happen is 0.9. And okay, so same way, so let y be the number of people, number of those treatment, chemotherapy treatment. Okay, so we know by this idea, so we know this y follow those binomial distribution 15. So here probability is 40, right? So both of them actually is a binomial distribution. So we separated these two treatment. Yeah. So for x, for radiation treatment, there are so many, right? So for those chemotherapy treatment, we have so many. So the cost the insurance should pay for those, pay 202, right? Pay those treatment 2, those treatment 3. So total pay actually is just equal 2x plus 3y, right? So now, so the problem, so now it's easy. So we want to find VT, variance of T, variance of T, so equal 2 square 4Vx plus 9Vy. So because x and y follow binomial distribution, so binomial distribution, so we have this, this formula, variance equal NPQ for binomial, right? NPQ. So here we can find that this N is 15, P is 0.9, Q is 0.1. So for those, okay, 15, the P is 0.4 and Q is 0.6. So for this problem, we want to find expected number of patients with expected number of those advanced stage cancer, those people, number of those people, giving that at least one selected from at least one of the selected patient has early stage cancer. So this is a conditional expectation. So let's say, so let the x be the number of patients, number of from early stage. Early stage. So just number from early stage cancer. Yeah. So y is this number of advanced. The y is the number from advanced. So what do we want to find? Find this probability, right? The expectation of y giving this x larger than 1. So here we can, let's say we can find the distribution for y. So y can be, let's say, so y is so the story is just like that. We for all people, so we split all people. 20% is source all stage, and 10% from advanced, and others, the 70% others. So here we just, from the population, we just pick 6 patients. So from here just pick 6. So these 6 can be all from early stage, right? Or 5 from early stage, then 1 from others. So here we have some trouble. These 6 pick how many from each part. We have too many cases, right? We can we put 6 into 3 parts of from here pick some, from here pick some. So So we find those the distribution for y, the conditional distribution for y looks like complicated. So here we find a better way to solve this problem. Okay. So we check it out. Forget this condition. Let's say how about ey. So for ey we have this formula for ey. So we can for ey we have two cases for x x equals 0 or x at least larger than 0 or at least 1, right? So we have this. We can check there's two cases. X equals 0. Then says conditional expected y. So when x equals 0, right? So this expectation is conditional expectation. So plus so x larger than 1. So then here y x larger than 1. So we use this equation. So we can solve for this condition, solve for this, for solve. Okay. So let's check like ey. Let's define ey. So ey. So what is y? So y is like we from here we pick 6, and so number of we picked from advanced. So this is why, let's say this is why pick from advanced is 10%, not from this part is 90%, right? So we find this y followed by binomial distribution. Okay, so here's a key point. This y follow this binomial distribution. Like you pick 6, so you can pick for each one. Maybe you can pick from this part or not from this part, right? So this total number picked from this part is just the binomial distribution. So you just try 6 times, and each time you just pick from this part is 10%. Okay, so this is why. Yeah. Okay, so this ey is very easy. Let's ey equal np, so equal np, so equal 0.6. Okay, so ey is easy. So how about those this part px x equals 0 is easy, right? X equals 0. What is x equals 0? Means we just pick 6 people, and from this part pick 0. So we say pick from this part 20% 2.2. So not pick point A. So this is point A happen 6 times, right? First one not picked from this part. Second one not from this part, right? So x equals 0 is we find easily. So how about this one? So we want to find expected value, conditional expected value. So when x equals 0, so when x equals 0, so this is when x equals 0, so meaning from this part we do not pick. So from here pick 0, so only so pick 6 from the 2 parts, right? Pick 6 from the 2 parts, either this part or this part. So original probability is here is 10%, right? 0.1, so here 0.7. So because we guarantee the conditions from here pick 0, so we can forget this part. Okay, so this y we can regard this is also binomial distribution. We just pick 6. So then, like from this part, from advanced part, pick 1. So what is the chance for this? Before is 0.1. So by now we need to adjust this. This is total probability point A. So this is actually 1 over A. So 1 over A chance pick from this part. So 7 over A chance pick from this part. Okay, so this expectation is, so we say this one so equal 6 times 1 over A, right? Or this equal 0.75. Okay, so then we just finally check what is the probability that x larger than 1. So this probability is also easy, right? So we larger than 1, so equal 1 minus x equal 1 minus px equals 0. So this equal 1 minus 0.86. So now we have everything, so then we can find, we can solve for this equation, find this. Okay. So this formula is also very it's really useful, and it's just like a conditional probability, like for whole probability formula. Find this probability. So check this case. So find expectation. So whole expectation is just check like under this condition, this expectation, and under that condition, the expectation. Okay. So for this one, we want to determine this px probability. So px is just the probability that x equal x. So this is px. Okay. We want to find this probability. So what is this x? So let's check. Okay. So this is like we just pick 4 integers. Pick 4 integers. There's 4 distinct integers are choosing from the first 12 positive integers. So this means like from 1 to until 12. So from here, pick 4 integers. Okay. So what is x? X is the second largest of these 4 numbers. Okay. Okay. So for this probability, let's say, so second largest. So let's see how to find this probability that x equal 2. So what is the 2 meanings? What is this meanings? Like so, this number should be like 2 is second. So here should have one number. Then here should pick another two number, right? So such a probability, this is just only from, so this probability is, so second largest number is 2. So here totally is, we just pick from 12, pick 4 randomly. So this is we guarantee. So what the chances? The second largest is 2. So first one should be 1, right? So no other choice. 1, 2. Things only here. We so for there's a 10 number, so we can from there's a 10 number pick 2, right? So here, so we guarantee second largest number is 2. We just pick 1, 2. then pick another two number, right? Okay, so if x equal k, or x equal x, so this means this is x. Okay, so from here we should pick 1, and from here pick 2, right? So there's a probability, so we understand it. Let's here randomly pick 4, and so from this part pick 1. So here how many numbers we can pick 1? I think it's x minus 1 number, right? From this x minus 1 number pick 1. Then from other part, so this one is x, then this is 12 minus x. So from those, from so many numbers, we just pick 2. Okay. Okay. So what is this? So this is just, let us see, this is just x minus 1, and here so 12 minus x, 11 minus x, right? Yeah, so divide up some constant, so we can check the answer is D, right? Or D or C. X minus 1, 12 minus 8, 11 minus 6. Yeah. Okay. So determine D or C, we just do some calculation. So here, let's say divide by 2. Okay. Yeah. So what is 12 choose 4? So that's just like that, right? 12, 11, 10, 9. So 1, 2, 3, 4. Okay. So here also have 2, right? So divide 2 and that's number. Okay, so this is just some calculation, yeah. Okay, so for this problem, let's say we want to find a calculate the C. So what is C? So this is like the loss deductible is this. So loss follow there's normal distribution. So suppose there's x loss. Okay. So this x loss follow normal distribution with mean thus, and the standard deviation is C. Okay. So we want to find this C. So the condition is this, like the probability that the loss is less than k is this. So this means like this x less than k, so this k equal, so we don't know this k, yeah. Okay. So then we have another condition. So given that the loss exceeds the deductible, exceed the loss, so loss, there's a condition like loss, so the loss exceeded deductible is thus. Under this condition, let's see, okay, okay, there is a probability, so there's a probability that is less than k. So x less than k under this condition is 0.9500. Right. So we need to find this C. Okay. Okay. So here we need to change general normal to standard normal. So let's see. So from the condition, that's all condition one, equation one, we get this. So x less than k is just changing to z, right? C less than k minus this, and this standard deviation c. This probability is this. Okay, so check the normal table. We can find this number k minus 2 minus 12, yeah, 12 0 0 0 over this c equals this number. So we just need oh, let's say this number. So we need to check from the table. We find this equal 1.73. Okay, so from table we get this number. Okay. Okay, so then we check condition 2, right? So this conditional probability equals this, equal px larger than this, and so here px larger than this and less than k. So such a probability is this. Okay. So x larger than x larger than 1000. So we need to change this, like let's say this equal so this probability equal just equal so here so x larger than or less than x so between this is x larger than less than k is just less than, let's say, so between this 1 0 0 0 to k, such a probability just less than k and less than 1000. So this equal just p x less than k minus p x less than 1000, right? Okay. So here's one larger thing, so we just change this as 1 minus. Okay. So we know x less than k, we know. Okay, so only we don't know x less than 1 0 0 0. So we put this as, let's say, this is now x less than k. We find x less than k is this 9582. 9582. So this one we don't know. We put this as x. So here 1 minus x. So such a probability is okay. So we can solve this equation. We can find this x. So we find this x equal some let's say x Okay, just solve this x, yeah. Okay, so let's see. 9582 minus x equal 95 minus 95x, like this, right? So move x to here, 005x. So here 00082. Yeah. So we can find this x. Okay, I think find this x is so here just a little bit calculation here. Okay, suppose x equals this, then we find this like okay, x less than this equal this. Okay, so then changing to standard normal, so this become z less than. So here this minus mu is 12, so minus mu, so become negative 2000 then over c, so this probability equals this. So then from here, check the table, we can find this number. Okay, then we can find this c. Okay. Okay. So from the table, we find this alpha equal alpha is let's say like so. This just like this, right? Here's 0. We want to find this cutoff point such that this is 16%, like 16 4%. So we find this equal negative 970. So we find this equal this alpha equal 978. Okay, so this c equal just equal 2000 over like this. Okay, so for this problem, let's see. So here, loss x for this distributing from 0 to b, rather from 0 to 10, 100, 1000, and the deductible is 250. So 250. So we want to find the difference between the median and the 20th percentile of payment of the insurance company. So just a payment. So media, just we want to find the media of payment minus the 20th percent payment. So let's say so the so let the y as a payment. Okay. So we want to find this cutoff point that is 50%. So such a cutoff point is this is median. Okay. Okay, and So find this. So let's say, so payment, so 50%. So we say the payment is here is y equals 0, and so here is just x minus 250, right? So we want to find this cutoff point such that so y less than a become x less than a plus 250, right? So this cutoff point is 50 half percent. No, half probability is 50. So 50 is we know this cutoff point. This a plus 250 should equal 500, right? So we find this a equal 250. Okay. So then what is 20%? 20%, we want to find this y less than b or less than, or we also can equal b, such that this is 20%. Okay, so 20% we say like y here, y equals 0. So we find y equals 0, such probability is already 1/4 or 25%, right? Okay, so we say the 20% is just the any point here. So we can say this b equals 0. So b equals 0. Okay, so a minus b equal just the 250 minus 0. Okay, so for this problem is bivalent normal distribution. So for those problems, we need some formula. So it's hard for me to remember the formula. So here, let's say, like giving that just a conditional. So let's say, we want to find the probability. So this under the condition. So we need to know the conditional distribution. So let's say, suppose A component A is we denote this as x, this is y. So what we want to find is this probability, right? We want to find probability this y is less than thus, giving that this x is thus. So the conditional distribution for this y, so we here we have used this formula. We say if for bivalent normal for conditional, so we have this like this y giving x, giving this x equal x. These things follow this normal distribution. Mean is mu y plus low, so low covariance, low, then sigma x, sigma y. So here's this x, x is the condition, x when x equals this is x. So minus mu x. and the standard deviation is standard deviation of y, but multiply the says 1 minus rho square. So this rho is correlation. So we need to know this formula. So otherwise, we cannot solve such a problem. So for this problem, I think like for me, I just give up because I cannot remember the formula. So hard to remember. Okay, so once if we know this this conditional distribution, then such a problem is easy. Okay, so those are all those sample problems. So we can stop here, and thank you for watching. Thank you for your watching.